Every person in every case of lung cancer is different, and so the course to diagnosis is often individual as well. You may know this from personal experience, and I certainly do because my grandma's course to diagnosis was very atypical. But to at least start a discussion about diagnosis, let's stick to a fairly standard course, okay? Since it's estimated that about 90% of all lung cancers arise from smoking, let's give our patient, we'll name her Ollie, a cigarette. And let's say that over the years she developed a smoker's cough, but decided to see a doctor one day when she was feeling like the cough was increasing, and at times she was coughing up bloody mucus, and she's consistently running a fever. Her physician would probably immediately order a chest x-ray to get a picture of what's going on inside of her lungs. And here's my drawing of what a chest x-ray film might look like. And let's say here in the lung is a round, suspicious-looking, dense mass. It would almost look like she breathed in a coin. Now, a coin appearance on a chest x-ray could actually be a type of pneumonia. So, pneumonia. And the radiologist might wonder if that's exactly what's going on with Ollie, considering smokers are prone to lung infections, right? But pneumonia will clear, or at least it'll begin to clear, in a few weeks with rest and antibiotics. So here, Ollie has antibiotics, and she takes them, and in a few weeks comes back for another x-ray, and the radiologist finds that the coin mass is maybe a little bit bigger, maybe about the same size, but either way, it hasn't gotten smaller, so Ollie probably doesn't have pneumonia. So I'm erasing that here. But be careful, because this doesn't automatically mean that Ollie has cancer, and a few other tests need to be done to rule out that this might just be an outgrowth of normal, healthy cells. One of these tests is a computed tomography scan, or a CT. And let's say Ollie goes and gets one to get higher resolution x-ray images to compile into a 3D image, making it easier to determine the size of the mass in her lungs. She might also go for a PET scan. A PET scan stands for a positron emission tomography scan, and it's used to determine if the cells are using a large amount of glucose. Since we know that cancer cells divide rapidly, they have a high demand for energy. And that means that they're going to use a lot of glucose and will appear very bright in scans compared to background tissue and normal cells. And if the mass is a larger size or growing in size when compared to additional future CT scans, and if it appears bright in a PET scan, it's worth taking the next step, which is more invasive, but is the only way to definitively diagnose cancer, by getting a sample of cells from the mass. So let's leave the medical images behind and discuss the procedures here on a drawing of the left lung. I should start by saying that sometimes an invasive procedure can be avoided. For example, if cancer cells are found in the bloody mucus that Ollie is coughing up. But this doesn't frequently happen, and so there are a few options for physically going in and removing the cells. Which option is used often is decided by the location of the cancer cells. What I mean by this is, see this blue here around the lungs? What I'm trying to show here is the pleural space around the lung that's filled with a protein-rich fluid that cradles the lungs. And sometimes cancer cells spread to this space, and that's called pleural effusion. And it causes this inflammation, leading to an increase in the volume of the fluid. And if this happens, it would be visible on Ollie's x-ray, because where lung tissue used to be, it's now being covered by this fluid. And an oncologist may decide to pass a needle from the outside of the body into this space and take a sample of the fluid, including the cancer cells, which would be floating around in it. But let's say Ollie doesn't have pleural effusion. Medical imaging shows that the mass growing in her lung is closest to the outside of her body, like if they were here. Well, then the oncologist may decide that it makes sense to pass a needle from the outside of the body through the pleural space and into the lung itself, where a biopsy of the tissue can be taken along with cells from the mass. And for this next option, let's erase this mucus And let's say that the mass is growing in one of Ollie's major airways, like right here. It might be easiest then for the oncologist to insert a tube down the back of Ollie's throat in a procedure called a bronchoscopy. This allows for viewing of her lung internally, and an attachment on the tube can be used to take a biopsy of the lung tissue and the cells. But any way that the cells are obtained, they're going to be sent back to the lab and determined if they're cancerous. And this is done by looking at them and looking for hallmark signs of cancer, like specific mutations in their DNA. Early discovery and diagnosis has a dramatic impact on lung cancer prognosis, and so the sooner the diagnosis is made, the better.